Welcome to the Explainer. Today, we are completely demystifying the whole alphabet soup of artificial intelligence. Because we're moving way beyond those simple chat interfaces we've all gotten so used to. We're literally entering the era of the autonomous agent.
So let's kick things off with a bit of a provocative question, just to challenge our assumptions here. Is ChatGPT the only kind of AI? Now, obviously, generative text models have completely dominated the headlines, and our imaginations, honestly, but they are genuinely just the tip of the iceberg. If we really want to understand where artificial intelligence is heading, we've got to look a lot deeper.
Because here's the thing. To build a truly autonomous AI agent, one that can actually knock out complex tasks for you in the background, you absolutely cannot rely on just a single chatbot brain. One size simply does not fit all. You need a highly diverse toolkit, packed with specialized capabilities for all kinds of different jobs. Think about it. You wouldn't hire a poet to fix your plumbing, right? Well, AI is exactly the same way.
All right, so here is our roadmap for today's Explainer. First, the AI Agent Toolkit. 2, Generalists and Specialists. 3, Adding Sight and Logic. 4, Taking Action and Downsizing. And finally, number 5, Orchestrating the AI Future.
So let's dive right into Section 1, the AI Agent Toolkit and those 6 core models.
If you want to build the ultimate AI ecosystem, developers are relying on 6 foundational building blocks. You've got your GPT, MOE, VLM, LRM, SLM, and LAM. Now, if that just looks like a giant bowl of foreign alphabet soup right now, seriously, do not panic. We're going to unpack every single one of these, and by the end, you'll see exactly why a true AI agent is a whole lot more complex than just a basic chatbot.
Moving right along to Section 2, Generalists and Specialists, the foundational AI brains.
Let's start with the one you probably know best, GPT, or Generative Pre-trained Transformer. This is our generalist. Basically, information enters the model and passes through these massive, deep layers of neural networks. And because it's been trained on an unbelievable scale of text data, it completely excels at broad tasks. We're talking everything from writing poetry to coding complex software. It leverages its entire massive network to give you a contextually relevant response. It's brilliant for sure, but man, it requires a staggering amount of computing power.
And actually, that brings us to MO, which stands for Mixture of Experts. I like to think of this model kind of like a super efficient corporate dispatcher. So instead of waking up the entire company for one simple question, it uses a gate network. This gate evaluates your prompt and routes it only to the specific specialized expert subnetworks that are actually equipped to handle it.
The contrast here is absolutely crucial to understand. While GPT uses its whole entire brain for every single query, which burns through massive amounts of server electricity, MOE achieves massive scale with incredible computing efficiency. By only activating the specialized parts it actually needs, MOE saves immense computational energy, and it does it without sacrificing any brain power.
All right, on to Section 3, Adding Sight and Logic, how these things actually see and plan.
First up here is the VLM, or Vision Language Model. This essentially gives the AI the superpower of sight. It processes text and images simultaneously, combining them in what's called a multimodal fusion layer. What that means for you is, you could literally show the AI a quick photo of the random ingredients in your fridge, and it won't just see tomatoes and eggs. It'll actually understand them and instantly spit out a recipe for, say, a frittata.
Now, when it comes to pure logic, we turn to the Large Reasoning Model, or LRM. These models don't just spit out fast, fluent text. They engage in deliberate, slow-thinking logic. An LRM will take a really complex problem, break it down into individual subproblems, execute specific reasoning steps for each one, and meticulously validate its own work before it ever presents you with a final plan. It's almost like having a master strategist in your pocket.
Next up, Section 4, Taking Action and Downsizing. Let's look at real-world interaction.
So the Large Action Model, the LAM, has the absolute superpower of execution. LAMs don't just sit there generating text. They take real-world action. An internal planner sets a goal, and then an executor actually reaches out into the digital world. Imagine telling your AI, hey, plan a trip to Tokyo. The LAM will autonomously trigger search engines, access your personal calendar, connect to airline APIs to actually book the tickets, and even reserve the hotel. It'll even adapt in real time if a flight happens to be full. It's a real game changer.
But conversely, what if you need an AI that doesn't rely on some massive energy-hungry server farm somewhere? Well, enter the Small Language Model, or SLM. These models trade that massive scale for ultimate speed and privacy. They're built for what we call edge devices, meaning they run directly on your hardware. They're fine-tuned via knowledge distillation, which is basically like a seasoned professor passing down only their absolute most crucial lessons to an undergrad student. The result? A lightweight, lightning-fast AI that can run completely privately, right on your smartphone, entirely offline.
Finally, let's wrap things up with Section 5, orchestrating the AI future and looking at the complete AI anatomy.
And this all brings us to the complete AI anatomy. As you can see, we aren't just looking at a list of random disconnected models anymore. This is a highly cohesive toolkit. By combining the broad, general knowledge of GPT, the amazing efficiency of MO, the vision capabilities of VLM, the deep, structured logic of LRM, the local privacy of SLM, and of course the autonomous execution of LLM, developers aren't just making better chatbots anymore. They are literally engineering digital workers that are capable of navigating incredibly complex, real-world workflows.
Which leaves us with a pretty thrilling and maybe slightly daunting reality. We are rapidly approaching the day when your own personal assistant will live right on your phone, see your screen, reason through multi-step problems, and execute real-world tasks totally autonomously. So when your AI agent finally possesses all of these specialized superpowers simultaneously, the question really isn't what can it do for you, but rather what will you be able to achieve when you no longer have to do all the busy work yourself. Thanks so much for joining me on this explainer today. Keep learning, and I'll catch you next time.